video about partial derivative. You have to differentiate implicitly about z, or the function which is equal to z equals e exponent x sine y plus z, to find the first derivative of z. And again, you have to find a directional derivative of the function f of xy, which is equal to x squared plus 3y squared at the point P, which is 1, 1 in the direction of the point Q, which is 4, 5. And the third question is also saying the temperature in degrees Celsius at the point xy on the surface on a metal plate is given by T xy, which is equal to 80 minus 3x squared minus y squared, where x and y are in centimeters. The question is saying we have to find A, the direction from the point minus 1, 5, where the temperature increases most rapidly, and B, the rate increases, where the rate also increases. So to solve the first question, just write the function that z is equal to e exponent x sine y plus z, and we say let f of x, y, z be equal to z minus e exponent x sine y plus z, and also we say f of x, y, z, fx. We are differentiating with respect to x, or we are differentiating with respect to each variable. So fx will be equal to e exponent x multiplying 1 sine y plus z, and also fz will be equal to 1 minus e exponent x equals y plus z multiplying 1. But to finalize your answer, we say e exponent x equals y plus z minus 1. That is f of z. And also we proceed to find the derivative of y. The derivative with respect to y, which will be equal to minus e exponent x cos y plus z. Anytime you get this type of a function, you have to first check the number of variables in the function. So this, you can see that the number of variables in the function, we are having different variables, that is 3 different variables, that is x, y, and z. So find the derivative with respect to each variable. So we say our final therefore, we say and hence the partial derivative dz over dx equal to minus fx over fz, which will be equal to minus e exponent x sine y plus z all over 1 minus e exponent x cos y plus z, which we can finalize as e exponent x sine y plus z all over e exponent x cos y plus z minus 1. And again the partial derivative for dz over dy will be equal to minus fy over fz, which will be equal to e exponent x cos y plus z all over 1 minus e exponent x cos y plus z. So these are the partial derivatives of the function. We will say hence the z over dx will be equal to e exponent x sine y plus z all over e exponent x cos y plus z minus 1, and dz over dy will be equal to e exponent x cos y plus z all over 1 minus e exponent x cos y plus z. Let's move to the second question.